absolute value graphs. Absolute value graphs look like a V when you make straight like that. So if you think of it's called a parent function, it's like the starting graph of the absolute value. Now, if we were to choose points to put into the equation y equals the absolute value of x, what's the absolute value of 0? 0. So you'd have a point at 0, 0. What's the absolute value of 1? 1. So you'd have a point at 1, 1. If you did the negatives, the absolute value of -1 is still positive 1. So there would be a line over here. Now that gives you the curve. You could do 2, 2, and -2, 2, but it's going to be a V. Now again, think of the important parts of that. It starts at 0, 0, and the next points are just up 1 over 1 in both directions. Okay? It forms a V. So we're going to be transforming this, which means we're scooting around this V. So if you ever have something grouped in the absolute value symbols with the X, that is a right and left translation, a horizontal translation. So if it says minus some number, you're actually going to shift your V to the right that many places. If it says plus H, you're going to shift it left that many places. Number outside afterwards that's being added or subtracted, that tells you how far up or down you're going to shift that absolute value graph. So if it's plus, you shift it up. If it's minus, you shift it down. Now, our default is to always just find that vertex and just go up 1 over 1 in both directions, and that creates our V. But sometimes you might see something in front of the absolute value symbols. I call it my slope-ish number. So again, it's almost always up 1 over 1, like that. But if that number is like 2, we would just go up 2 over 1. If it was 3, up 3 over 1 in both directions. If it's negative, instead of going up 1 over 1, you can just go down 1 over 1. That's it. It's pretty easy. We're just shimmying around this V-shaped graph. So this first one just has x minus 1, and it's in the absolute value symbol. So that's the right and left. So this would just take the V and move it one place to the right. So take your vertex, which is usually at 0, 0, just go one place to the right and make your new vertex. And then from that dot, you just go up 1 over 1 in both directions. And you can keep going in that direction. That's it. I promise it's not that hard. Here, it has a minus 3, but it's not grouped with the x, so that's your vertical change. So this would shift the entire V down 3. So start by going down 3. From that point, you go up 1 over 1 in both directions. That's almost too easy. Let's throw it in where we have multiple transformations in the same one. Now this one has the plus 4 grouped with it, so that would be right and left. So this is going to go left 4. Whoop, there's the vertex. But we also have that negative in front of the absolute value symbols. So instead of going up 1 over 1 both directions, we're going to go down 1 over 1 both directions. Down 1 left 1, down right 1. That's it. So this has a negative in front, so it's going to be an upside down V. So this one has the minus 4 in the middle, so that would shift it right 4. The plus 1 at the end would shift it up 1. So go right 4, up 1. We have a negative out in front. It's like a -1 slope of both directions. So down 1 over 1, down 1 over 1. We can keep that going. Wow, we'll pretend like I hit any of those dots. There we go. Let's keep cruising. These go pretty quick. So this one, we go right 4, down 1, right 4, down 1. And we have that negative out in front, so we go down 1 over 1 in both directions. Minus 1 in with it would shift right 1. Minus 2 at the end would shift down 2. Right 1, down 2. In front we have the negative, so down 1 over 1 in both directions. Come on, you know this isn't bad. getting a little congested here. Plus 4 grouped with it, so that would be left 4. Plus 2 not grouped with it, that would be up 2. Left 4, up 2. And then to find our next point, we use that negative. So from there, we go down 1 over 1 in both directions. That was a pretty rough straight line on the right side there. All right, here we go. Number 8. We got a left 2. We got a down 3. Left 2, down 3. Negative out in front. So we go down 1 over 1 in both directions. Draw a line through the dots. You know the song, guys. Don't pretend like you don't. Don't pretend. Minus 3. Oh, that's a right 3. Minus 2. That's a down 2. Right 3, down 2. In front, there's nothing. So we just go, well, there's an invisible 1. So we go up 1 over 1 in both directions. Woo! Woo! Minus 3. Hey, that's to the right 3. Plus 1. Oh my goodness, that's up 1. Right 3, up 1. And then up 1 over 1. Oh, wow. Minus 3, right 3. Plus 3, up 3. Right 3, up 3. And we got the negative out in front, so we should go down 1 over 1. I gotta sneeze again. Can you believe it? Here, plus. Plus 3 grouped with it. That's left. Minus 3 not grouped with it. That's down. Left 3, down 3. Here we go. Up 1 over 1 in both directions. I know I'm going pretty quick, but it's the same stuff over and over, so pause if needed. Here, minus 2 grouped with it, that's right 2. Minus 2 not grouped with it, that's down 2. Right 2, down 2. Then we have that negative out in front, so we go down 1 over 1 in both directions. You know what's another way that you can graph this if you forget? You could create a table, choose your own x values, substitute them into the equation, solve it, whatever you get would be your corresponding y for that coordinate. That's a lot of work. That's how we used to have to do this back in the day when we first started graphing stuff. So number 14, if you can remember the transformations, it's so much less work and it still gets you a correct graph. So we would go left 1 and down 1. We have that upside down V here. Left 1, down 1. From there we go down 1 over 1. Ooh, 15. All I'm seeing is a plus 2 outside of it. That just shifts it up 2. We don't have a right or left shift on there. Positive 1 out in front, so we just go up 1 over 1 in both directions. Oh, 16. It's the first time we have a different number out in front. Let's do the other stuff the same. We're going to go right 1, down 2. Now, instead of going up 1 over 1, because our slope is now 3, our slope-ish, we're going to go up 3 over 1 in both directions. 1, 2, 3, over 1. 1, 2, 3, over 1. And then you can keep that going, up 3, outside 1. So this becomes a skinnier V when you do that. Do we have more on this page? Nope. 3 more. 17. Ooh. The minus 1 was shifted right 1. This minus 1 was shifted down 1. And then now our slope-ish thing is negative 2. So we're going to go down 2 over 1 in both directions. We kept that going. Awesome. All right. Plus 1 is left 1. Minus 1 is down 1. Left 1, down 1. Our slope-ish thing is negative 2, so go down 2 over 1 in both directions. One more. Aw, I wanted to graph more absolute value functions. Plus 3 would be left 3. Minus 1 would be down 1. Left 3, down 1. Our slopish thing is negative 3, so we shall go down 3 over 1 in both directions. That's it, man. We just did 19 with tons of transformations. You nailed it. We did it. We're done.